Hey everyone, welcome to the Azure Virtual Data Center Workshop. Now this workshop is part of the Azure Citadel, an incredible resource which has been developed by our cloud solution architects and designed to help you build real-world solutions in the Microsoft cloud. Today we're joined by Adam, who is going to walk us through building out a solution. Adam, would you like to give us a brief introduction?
Yeah, sure. So, hi everyone, my name's Adam Raffe. I'm a cloud solution architect within the UK partner organisation at Microsoft.
So over the course of the next couple of hours, we will not only build out our environment, but really understand what the components are, why the segregation is important, and how it all fits together. We will then look at configuring routing, security and monitoring before changing focus to access control. And if you want to follow along, then feel free. Simply head over to azure.com to sign up for a new account and then into the Citadel repo on GitHub to download the lab. When you're ready, we'll begin. So I guess before we start building out our environment, we need to ask the question why. I'm fairly confident that by now the IT community is aware of the benefits of the cloud. But why the need to segregate the resources into a virtual data center? Why not everything in one place?
So in the early days, cloud solutions were designed to host single, relatively isolated applications. And this approach worked well, but as the benefits of the cloud became apparent and multiple large-scale workloads were deployed, addressing security, reliability, performance and cost concerns became vital throughout the lifecycle of the service. A virtual data center is essentially a collection of separate but related entities with common supporting functions, features and infrastructure, allowing easier operations, management and compliance audits.
Okay, so what you're saying is then that by breaking it up into more manageable pieces, not only do I get the ability to be able to step away from a monolithic design, I'm also given the opportunity to enjoy granular access control. And by doing so, I guess that what we're able to see is a more manageable workload that could be delegated into specific teams.
Yep, that's absolutely right.
Perfect. So let's take a look at what we're going to be building out today. Now looking at the diagram, we have 4 key areas. We have an on-premises network, and then we have 2 spoke networks, which are all connected into a centralized hub by means of virtual network peering and VPN tunneling. And by the looks of it, we have a Cisco virtual network appliance, which will be handling all routing between the sites.
Yep, that's correct.
Now this looks like it's going to take a while to deploy. Are you sure we're going to get this all done in a single session?
So if you were to do this manually using the portal, yes, it would take you quite a while. However, we're going to use an Azure ARM template to build the environment instead.
Okay, so this is largely going to be scripted then?
Yeah, that's right.
Okay, so now, as I understand it, ARM templates or infrastructure as code are a super simple way of deploying resources quickly and repeatedly.
Yeah, so with Resource Manager, you can create a template in JSON format that defines the infrastructure and the configuration of your Azure solution. By using a template, you can repeatedly deploy your solution throughout its lifecycle and have confidence that your resources will be deployed in a consistent state.
Okay, but they look super scary. How are we supposed to know how to code all of this?
Well, that's the thing. There's no coding as such. ARM templates use declarative syntax, so you state what you want and the resource providers do the rest.
Awesome. So ARM templates allow me to declare the types of resources that we would like to have, the names we would like to give them, and any properties that should be associated with them.
Yep, that's right.
But looking at this diagram, it appears that we have a whole bunch of templates to deploy. Are you saying that by just running the master template, what we're actually doing is invoking several?
Yeah, that's exactly it.
That's pretty impressive. Could you briefly explain what each does?
Sure, so essentially a single master template, the VDC networking master.json, is used to call a number of other templates which in turn complete the deployment of virtual networks, virtual machines, load balancers, availability sets and VPN gateways. The template also deploys a simple Node.js application on the spoke virtual machines.
Okay, so how do we go about deploying the solution?
So the first thing that we'll need to do is to create our resource groups. Now, I'm using the built-in Cloud Shell in the Azure portal, and this provides you with a Bash CLI environment.
Bash? The born-again shell is in Linux.
Yep, that's right. So open source is a first-class citizen in Azure.
But we can also use PowerShell though, right?
Yeah, correct. So I'm using a simple loop here to create the resource groups that we need.
And as we said, we are separating the resources into separate resource groups so that at a later stage we can use that to gain better granular control.
Yeah, absolutely. So once this is done, I'll quickly check in the portal to make sure our groups have been created.
Okay, so what's next?
So we're going to kick off the installation by running the command az group deployment create. Now the first thing we'll do is we'll give this deployment a name. We'll call this VDC create in this case. We'll also specify the resource group we want to deploy into, in this case our VDC hub resource group. And then finally we're using the template URI parameter to pull the JSON template from GitHub.
And I'm assuming that this is going to take a while.
Yeah, this is going to take about 45 minutes or so.
Okay, so let's use some of that time to chat about what we're going to do once the deployment has succeeded. Then, with the power of video editing, I'm sure we'll be in a great position to continue. So let's begin to understand the components that we will use in the solution. Now obviously we have spoken about how easy it is to deploy with ARM templates, but I'm guessing that we'll have some steps to complete on the back end of the deployment.
Yeah, we're going to need to do a few things. So firstly we'll need to configure the infrastructure, including connectivity and user-defined routes. Then we'll need to consider security and resource policies. From there we'll look at monitoring, and finally we will investigate identity solutions.
Okay, let's discuss these one at a time then and really make sure that we're seeing the bigger picture. Let's start with infrastructure. So we obviously have an external connection, which is pretty much common practice when building out a cloud solution. Now the way that I see it, this falls into two choices. We can either send data securely over the internet using a site-to-site VPN or by a private direct connection such as ExpressRoute.
Yeah, and this really comes down to cost and speed considerations, but with either of these solutions we'll need to go through a gateway.
And I guess if we follow on from that, network administrators will really want to think of ways that they can be more granular with the flow of traffic to and from the cloud resources. What can we offer to police this ingress and egress communication?
So we have a number of options at our disposal, but we'll want to consider things like user-defined routes, which will allow us to be focused on what enters and leaves the network.
And are we going to see this in the lab?
Yeah, absolutely.
So we can control the flow of traffic, but for companies, security is top of mind. What are we going to do in our lab that ensures that all of this is sufficiently locked down?
Well, we have a whole bunch of things at our disposal, but we're going to focus on building out our network security groups and Azure resource policies, whilst also taking advantage of the Azure Security Center to monitor and detect vulnerabilities.
Okay, and I guess with things like Azure policies, we're also able to define things like naming conventions whilst capping provisioning rights?
Yeah, correct.
And I'm guessing after security, monitoring will need to be considered so that we can identify and troubleshoot any potential issues in our VDC environment. What are we going to look at here?
So we'll start by looking at a feature called Network Watcher, and then we'll investigate NSG flow logs and also the Azure Monitor.
Now the Azure Monitor will allow us to set alerts and monitor metrics so that we have actionable events when thresholds are crossed.
Absolutely, yeah, we'll set this up and then we'll perform some stress testing of our environment to see this in action.
Okay, so the last thing that we will look at is identity. Now, having used Azure for many years, I realised that there are a number of ways that we can prove our identity. These include methods such as passwords, cryptographic keys and certificates. But I'm guessing that we'll be taking advantages of services such as Azure Active Directory and role-based access control.
Yeah, that's right. So access rights are controlled through permission assignments and role-based access control policies, which will offer fine-grained access management to our VDC resources.
So we will build out some users and groups, then assign them specific access rights to our resources through policies via Azure AD.
Yes, exactly.
Okay, let's jump back into the demo and make this all happen.
So the first thing that we'll need to do here is to deploy our Cisco Virtual Network Appliance. To do this, we'll navigate to the VDC NVA resource group and then we'll search for a Cisco CSR 1000V. Now we're looking for a specific model here. The one we're looking for is the 16.6 deployment with 2 NICs.
Okay, that's selected.
So once that's selected, we need to give the virtual machine a few parameters. So we're going to start by naming the machine VDC CSR1. We'll give it a username and password, so the username we'll use here is lab user, and you can give the virtual machine any password you like. We'll also make sure the VM is deployed into the correct resource group. Now the next thing we need to do is make sure we create a storage account for this virtual machine. So you need to have a unique name for this storage account. Next, we need to assign a public IP address, and we're going to call this CSR-PIP. We'll also assign a DNS label to the appliance. Now this needs to be unique as well. The next thing we'll do is select the virtual network. Now we want to put this VM into our hub VNet virtual network. So this is the one we're going to select. Then on the subnets, we will choose Hub VNet Subnet 1 as the first subnet and Hub VNet Subnet 2 as the second. When all that is done, we can go ahead and deploy the appliance.
Okay, great. So look, let's pause the video here and come back in a moment once that's finished deploying. Now, is there anything else that we need to consider?
Yeah, there's one more thing. So once the deployment has finished, we'll need to disassociate the network interface from the VDC CSR1 SSH security group.
Okay, and why are we doing that?
So later on in the lab, we will want to apply our own network security group to the CSR interface. Now, as you can only have a single NSG assigned at one time, we need to remove the automatically created one.
Okay. So what's next?
So let's take a look at the virtual networks of the resource group VDC Hub. If we click on the Hub VNet, you'll notice that we have an extra subnet in here called Gateway Subnet.
And this is for the communication between the two locations when we set up the site-to-site connection in a moment, right?
Yeah, that's right. Now if we navigate to the Spoke 1 load balancer in the VDC Spoke 1 resource group, we'll see that under backend pools, we have both machines configured as part of the backend pool for the load balancer.
Effectively distributing the workloads.
Yeah, that's right. So if we then click on load balancing rules, we'll see a single rule named demo app rule that is used to map the HTTP requests to port 3000 on the back end for our Node.js application.
Let's take a look at configuring our site-to-site VPN. Now the gateway has already been deployed as part of the template. So all we need to do now is configure the connections, right?
Yeah, exactly. So what we'll do is we'll go into our Hub GW1 gateway and we'll select connections. Now from here, we'll add a new connection named Hub to On-Prem. Then what we'll do is we'll choose On-Prem GW1 as the second gateway, and we'll use Microsoft 123 as the shared key.
And we will then need to reverse the process for returning traffic?
Yes, that's correct, yeah. We'll reverse the process, we'll create a new connection named On-Prem to Hub.
And how can we test this to ensure that the connections have been made?
So once the connection has been established, we should see a successful VPN connection between the on-prem and the Hub VPN gateways.
Okay, and I guess that we can verify the connectivity by inspecting the effective routes associated with the virtual machine?
Sure, if we navigate to the on-prem resource group and then look at the on-prem VM1 NIC, we should see that under support and troubleshooting, we have an effective route entry for the virtual network gateway.
Okay, so next we'll configure our virtual network appliance, which in my mind is essentially a virtual machine that runs specialized software and provides some kind of routing or firewall functionality.
Yeah, that's absolutely right. So what we're going to do first is open up our Cloud Shell in the portal again. And what we'll do this time is we'll use the Cloud Shell to obtain the public IP address of the Cisco CSR router using a CLI command. And we're actually going to use a query parameter here to pull out only the IP address from this command.
I see. So what you're typing there is query, and then from there you're pulling out all records and you're looking for the name and you're looking for the IP address. Yeah, so they should be our two columns that are returned in a table format.
Yeah, exactly.
Okay, what's next?
Okay, so once we have this IP address, we can use this to log on to the Cisco router and begin to configure our interfaces.
And this is just a standard SSH connection?
Yep, there's nothing special about this at all. Okay, so now that we're in, what we're going to do here is we'll set the two interfaces on the CSR to get their IP addresses from DHCP, and also to make sure that both of those interfaces are up and running.
Okay, and this is the Azure DHCP server, yeah?
Correct, yeah. This is just pulling the IP address from the Azure DHCP fabric.
Okay.
Okay, so now that we've done this, what we can do is we can use this show IP interface command to essentially verify that both interfaces do indeed have an IP address. So now that this is done, we'll return to our Cloud Shell and execute the same command again to obtain the IP address of the on-prem VM1 virtual machine.
Okay, and that's just simply doing a name change in your query string, yeah?
Exactly, yeah. It's the same command we used before, just with a different virtual machine name.
Okay.
Okay, so once done, we can now SSH into that on-prem VM1 virtual machine, which resides in the on-prem resource group. Now what I'm going to do here is, once I'm into this virtual machine, I'm going to SSH from that on-prem VM1 virtual machine to one of the interfaces on our Cisco router. Now what this is going to do is this will prove to us that the site-to-site VPN connectivity between the hub and on-prem is working correctly.
Now, as we can see, that succeeded. However, if we try and connect to the virtual machines that are hosted in the spoke networks, they're going to ultimately fail. Now, this is because we don't yet have the routing in place to support the connections, right?
Yeah, that's right. So what we're going to need to do is to configure our user-defined routing.
So a user-defined route, or UDR, is a routing table that is defined by the user and typically required any time that a network virtual appliance, such as our Cisco CSR router, is deployed. These will generally override the default routing that Azure sets up, so I'm guessing that we'll need to carefully consider the consequences of our decisions when planning.
Yeah, exactly. So what we want to do here is configure the user-defined routes to allow traffic to flow from the virtual machines residing in the spoke VNets to the VM in the on-premises VNet, and vice versa. And this traffic will flow via the Cisco router in the hub VNet.
Awesome. Let's jump back into the portal and get this configured.
Okay, so what we'll do is we'll create our first user-defined route using the Azure portal. So what we'll do is we'll navigate to the VDC on-prem resource group and add a new route table.
And our route tables are going to be similar to route tables that you would find in any type of router, yeah?
Yeah, absolutely. There's no real difference.
And they're just specifying the flow of traffic.
Yeah, correct. Yeah. So we'll name our route table on-prem UDR. We'll make sure it's in the right resource group, and we'll create it. So we'll give that a few seconds to create. Okay, so now that that's created, what we'll do is we'll create some routes to add to that route table. So I'm going to now add a route, and I'm going to call it spoke1 route. The address prefix I'm going to use here is 10.1.0.0/16, which is one of the spoke address prefixes. And the next hop is going to be a type network, virtual network gateway.
And the /16 would be a 255.255.0.0
That's right.
address.
Yeah,
Okay.
yeah. So I'm going to do the same thing for spoke 2 because we also need a route that points to the spoke 2 VNet. So this is going to be 10.2.00.
Okay, so it's the second octet that's defining the differences.
Yeah, that's right. Okay, now the last thing we're going to do here, once that's finished creating, is we're going to assign the route table to our subnet in the on-prem VNet. So we click Associate, we select the virtual network that we want, which is going to be on-prem VNet. And then we're going to use VNet subnet, on-prem VNet subnet 1.
Okay.
So what we'll do is for the remaining route tables, we'll use the Azure CLI to do that, as it's going to be a lot quicker. So I'm going to use this command az network route table create, and I'm going to give it a name, hub UDR, and I'm going to assign it to the VDC hub resource group. So we'll give that a couple of seconds to create.
And I guess while that's running, we can see that these command lines that we're typing into Bash are pretty self-explanatory, you know, with the tags, the name and the resource groups and so on.
Yeah, they are. They're very easy to get the hang of. Okay, so the next thing we'll do is we'll create a route to add to that route table. So this is exactly the same thing we did in the portal before, we're just using the CLI to do this instead.
Okay. And as you said, this gives you the added advantage of speed. If I'm adding multiple routes, then I can just key up on the keyboard and make some minor adjustments.
Yeah, that's right. I mean, you can also do this using things like ARM templates if you want. You can script this.
Okay. So there's a number of ways that we can achieve the same thing here.
Yeah, that's right.
It really comes down to personal preference and automation.
Yeah, absolutely. Yeah. So what we're doing here is we're creating a route with a next hop type of a virtual appliance. So virtual appliance in this case means our NVA or our Cisco CSR. We're using a next hop IP address of 10.101.1.4, which is one of our interfaces on the CSR router. And we're associating this route with our route table that we created in the last step.
Okay.
Okay, so we'll do the same thing again for the second spoke.
And we're just changing that address prefix.
Yeah,
to the
that's
2.
right. Yep.
Okay, so that's just finishing off running. What do we need to do once this is complete?
Right, so we have our route table created now with the routes in it. What we need to do now is actually associate that route table with our subnet, and the specific subnet we're going to use here is the gateway subnet inside our hub VNet. Okay, so now that that's done, what we're going to do is create another set of route tables for the spokes. So essentially it's the same process that we've just been through, but this time we're essentially doing it at the opposite end of the network. So we're creating some route tables in our spokes that point towards the on-premises network via the network, the Cisco CSRs.
Yes, I mean, I guess the thing to take away from this is even though we're configuring this as a virtual data center in the cloud, the processes are not that dissimilar to what we would have done on premises. You know, we'd need a route both ways.
Yeah, absolutely. Yeah, I mean, the rules of networking don't just disappear in the cloud. So we're creating our route tables here. Our spoke 1 and spoke 2 UDRs, and then we'll do the same thing again. We'll add some routes into those route tables. So it's going to be the same commands again. So AZ network route table route create. We give it a name. We specify the address prefix, which is going to be the address range of the on-premises VNet.
Okay. And again, they're /16s, yeah?
Yeah, that's right, yeah. So the next hop, again, is going to be the Cisco CSR. Now, one thing to bear in mind here is that this next hop is the other side of the Cisco CSR compared to what we did before, because we're coming from the opposite direction.
Okay, so when we talk about hop counts here, I mean, are we using static routes? Could we use things like OSPF and RIP, and are those available in the cloud?
Well, they are in some circumstances. So what we're doing here is essentially static routing.
Right.
That's what this is. Now, you can use things like BGP when we're talking about VPN gateways.
And BGP is the Border Gateway Protocol?
That's right, yeah.
Okay, so now that we have configured our routes, let's go ahead and validate connectivity between our on-premises environment and the spoke VNets. Now, this communication should occur through the Cisco CSR router that resides in the hub VNet. However, before we do that, we'll need to configure our peering to use remote gateways before connectivity will be successful.
Yeah, that's right. So what I'm going to do here is navigate to the Spoke 1 VNet inside the VDC Spoke 1 resource group. Then what I'll do is I'll select peerings, and I'm going to need to select the to hub VNet peering, and then I'll enable the checkbox next to use remote gateways.
And I'm assuming we're going to have to do this for the second spoke too?
Yeah, that's right. So I'll let this save quickly, and then I'll do exactly the same thing for Spoke 2.
Okay, so while you move down to spoke 2, I'm guessing everything that you do here we could also do in the CLI too?
Yeah, that's right. I'm using the portal here, but I could easily use the CLI or ARM templates to achieve the same thing.
Awesome. So now if I SSH into the machine named on-prem VM1 and from within it try to SSH into the first virtual machine inside the Spoke 1 virtual network, I'm going to be successful, aren't I?
Yep, we should be. So we'll try that now. So I'm just SSHing into the on-prem virtual machine here.
And I notice you're entering a password, but I guess we could have used a digital certificate for that too?
Yeah, we could have done. So now that I'm in here, I'm going to try and jump onto the Spoke 1 virtual machine. And that's successful, as you can see.
Great. So how do we now test that the load balancer is working?
Okay, so what we'll do is we can jump back to the on-prem VM1 virtual machine, and we can use this curl command to make an HTTP request to the load balancer's private IP address, which lives in Spoke 1. Now this is on the IP address 10.1.1.4, and what we're seeing here is that the command returns an HTML page showing some information such as page title, host name, system info, and more.
Okay, so let's now look at securing our environment. At present, our user in the on-premises VNet is able to access the VMs in both Spoke 1 and Spoke 2 on any TCP port. Now I'm guessing that we'll want to use the Azure Network Security Groups to lock this down?
Yeah, absolutely. What we want to do is allow HTTP and port 3000, which is the port that our application runs on. However, we want to prevent all other traffic from being allowed to talk to our Spoke VNets.
And what else can we do to lock down our environment? I'm guessing Security Center is going to be an option?
Yeah, that's right. So we can use Security Center to analyze our environment and further lock down our resources.
And policies that will give us a little more granular control?
Yeah, absolutely.
Great. Let's jump back into the demo and get this configured.
Okay, so from within the Azure portal, we'll first navigate to the resource group named VDC Hub. And we're going to add a new network security group here.
Okay, and a network security group, I mean, in my mind, that's like a virtual firewall, right?
Yeah, exactly. It's like an access control list.
Okay.
So I'm going to call my NSG hub NSG and click create here.
And this will take a little while to
Yeah,
create?
it may take a few seconds.
Okay.
Okay, so I'm going to jump to my NSG. I'm going to click on inbound security rules and create a new rule here. Now the first one I'm going to create is going to be called allow HTTP. And I'll make sure the destination port range is port 80 using TCP. And I'll click OK.
Okay, and I guess that we now need to create another 2 rules, one for port 3000 and then another to deny all traffic, right?
Yeah, that's right. So I'll wait for this rule to update, and then I'll create a new rule called allow 3000. Now I'm going to increase the priority to 110 here.
And why did we increase the priority?
So the priority is just, it's a sequential list of rules inside the NSG.
So this is effectively saying it's higher up in the list, right?
Yeah, that's right. Yeah. Okay, and I have one more rule here, which I'll create, called deny all.
Okay, but why do we need this third rule? I mean, is there not an implicit deny in place by default?
No, so a default rule actually exists inside the NSG that allows all traffic from every virtual network. So without this specific deny all rule in place, all traffic will succeed and the NSG would have no effect.
I see, so an important point to remember then.
Yeah, definitely.
Okay, so now we just need to associate the NSG to the network interface and test it out, right?
Yeah, that's right. So all I've done here is just gone into network interfaces and associated the NSG with the NIC0 interface on my CSR router.
Okay.
So what I'm going to do here is I'll jump back into the Cloud Shell. I'll SSH back into my on-premises virtual machine.
And while we're doing this, we should probably just state that this may take a few minutes if people are trying to replicate this at home, yeah?
Yeah, it sometimes takes a couple of minutes for the rules to take effect. So you can see here that I'm trying to SSH into my Spoke 1 virtual machine, and that's failing. If I now try the curl command again, that's successful.
Okay, so let's continue with the security theme and discuss Azure Security Center. Now, Azure Security Center is built into the portal and allows administrators to gain visibility into the security of their environment and detect and respond to any issues and threats. Can we take a couple of minutes to showcase the tool?
Sure, let me head into Security Center here. So as we can see, we have a kind of at-a-glance view of any security recommendations relating to compute, storage, networking, and applications.
Okay, and if I go ahead and click on recommendations?
So what you'll see is a list of security recommendations relating to various areas of the environment. So for example, the need to add network security groups on subnets and VMs, or the recommendation to apply disk encryption to VMs.
Okay, so definitely one that needs a deeper dive in a future video. But let's continue. So let's recap. In terms of security, we've specified the traffic that can come into our network, and we've identified potential security threats using tools such as the Azure Security Center. But what if I want to place restrictions on what admins can do? What if I want to define what VM sizes are allowed and mandate that encryption must be used for storage accounts?
Well, we could use something like Azure resource policies to lock down what can be done, and this can be done either at the subscription level or at the resource group level.
Okay, that sounds great. Can you demonstrate?
Sure, so let me navigate first to the VDC Hub resource group, and then we'll click on Policies in the menu.
Okay.
Now from there, I'll click on the Policies tab in the right-hand pane, and what we can see here is a list of available built-in resource policies. So what I'll do is I'll switch back to Assignments, and I'm going to assign a new policy with the following parameters. So what I'll do first is I'll select all of the Microsoft.network resource types. So this will allow me to do anything network related using this policy.
Okay.
So I'll call this allow network, and I'll use the same name for the ID as well. Okay, so once that's done, I can test this by heading back over to the VDC Hub resource group. And what I'm going to try and do here is I'm going to try and add a simple Ubuntu virtual machine. So I'll go through the normal VM create process. I'll give the machine a name.
Okay, I'm guessing it's going to make you get all the way to the end before it tells you it's not going to allow you to do it.
Unfortunately, it will, yeah. Yeah, so I need to go through all of the usual stuff here. So username, password, resource group.
So basically we're teasing people, right?
Yeah, exactly. So I'll just use the default settings as much as possible. I'll OK that. And then what we should see here is
our
validation failed.
Okay.
Yeah.
So that's great. And I'm guessing that if I need to, I could build my own policies?
Yeah, this is all fully customizable as well. So this is a built-in policy, but I could easily create my own.
Awesome. Fantastic. So we have now configured our connectivity and address security. Let's shift focus and discuss how we can monitor our resources in the cloud. And I appreciate that we have a whole bunch of solutions at our disposal, and it's probably a little unrealistic to cover them all, but can we showcase a few?
Sure. Okay, so let's start by looking at the Network Watcher tool. Now the first thing we need to do is enable this feature.
So this isn't enabled by default then?
No, that's right. So we enable the feature on a per region basis. So what I'll do first is I'll search for the region that I'm actually using, which is West Europe, and I'll click enable here.
And is there a charge for this service?
So there's no upfront charge for the service, but there is a small cost associated with things like logs and diagnostics.
Okay.
Okay, so now that this is deployed, what I'll do is I'll navigate over to the left-hand side of the screen, and under monitoring, I'll click on topology. Now I need to select the subscription that I'm using, the resource group, and also the virtual network that I'm interested in.
Okay, and then you'll see a graphical representation of the topology on the screen. But can you use it to view subscription limits?
You can. So what I can do here is select network subscription limits, and then what you'll see is a list of resources, including virtual networks, public IP addresses, and so on.
Okay, so we've just got to select our location first, yeah?
That's
right. Okay, I see. Perfect. Okay, so what about monitoring the information from our network security groups? Can I use Azure to detect and report on anything untoward?
Yeah, so we can use NSG flow logs to do this. Now these logs are written in JSON format, and you'll need to store them in a storage account. Now I created a storage account earlier on today. If you need to create one, you can use the CLI command shown here on screen. So we go into the NSG flow log section from the Network Watcher. We select the Hub NSG security group that we created earlier. From the settings screen, we change the status to on, select the storage account we just created, and then change the retention to 5 days before saving.
And I'm guessing that we'll need to generate some sort of traffic to make the thing work?
Yeah, exactly. So what I'll do is once this has finished updating, I'll go back into the Cloud Shell window from the Azure portal, and I'm going to SSH back into my on-prem virtual machine.
And let me guess, we're going to use the curl command to view the demo app on the Spoke 1 VM one we created earlier?
Yeah, exactly. So remember, nothing has changed from the exercise we did before. So I'm just going to execute exactly the same command again. Just use the curl command to view our application on the Spoke virtual machine. So that's successful. I'll do that a couple of times just to make sure. And then what I'll do is I'll try SSHing into my Spoke 1 VM again as well.
Now this is going to fail, isn't it, because of the policy that we created earlier?
Yeah, exactly. We've just kept that policy in place. Nothing has changed, so that's definitely going to fail. So what I'll do now is I'll navigate to the storage account that I created before and see if there's any information in here yet. Now, it can take a few minutes before we actually get the log information in the account. So we'll see what we have. So I can see here that there's no information yet. So we'll pause the video for a second just to make sure that we can get our information.
Okay, and we're back. How do we go about viewing our logs?
Okay, so we can see this container that's been created for us here now for the network security group flow logs. What I'm going to do is navigate all the way through this directory structure, which is quite long, but eventually we'll reach a file called pt1h.json. So I'm going to download this to my local machine. And I'm going to open this in Visual Studio Code, but you could use any editor for this.
Okay.
Now, if we look at this file, what we should see are a number of flow entries which can be inspected here. So let's start by looking for an entry for TCP port 80. So you can see here that we have an entry from 10.102.1.4 using port 80, and this has been successful. Now I can also search for entries for SSH, so port 22 as you can see here, and you can see the D flag which shows that this has been denied.
Okay, so what about network tracing? I mean, do we still use tools such as pathping and traceroute, or do we have something similar in Azure?
Yeah, so we can also use the Network Watcher to allow us to capture next hop information. So I'll go back into the Network Watcher tool here, I'll click on next hop, and I'm going to enter some parameters here that allow me to invoke the trace. So I'm going to use the Spoke 2 resource group this time, and I'll use the Spoke 2 virtual machine 1. Now the destination IP address I'm using here is my on-premises virtual machine. So after a couple of seconds, I should get some information back here showing me the next hop for this traffic flow.
Okay, and we can see that it's our virtual appliance, yeah?
That's right, this is the Cisco CSR.
Awesome. These are great, but it's all networking focused. What about the ability to monitor other services such as CPU and memory?
Well, for things like that, we have the Azure Monitor. Now, this is going to allow us to look at the metrics on a resource and even create alerts when thresholds are crossed.
And I'm guessing that we can then action these alerts, such as spin up another instance or notify an administrator?
Yeah, exactly. So let's go ahead and configure this. So from the Azure Monitor window, we can see that the initial view is set to the activity log, which shows a view of all our activity in our subscription. And it allows us to filter on time span, event severity, and resource type. Now I can select metrics on the left-hand side, and then at the top of the screen, I can filter to our on-prem virtual machine from the resource drop-down menu. Now from there, you'll notice that I can select a number of metrics such as host percentage CPU and disk read bytes. Now the other thing we can do here is we can configure alerts when a specific threshold is reached. So I'm going to go ahead and create an alert here, and I'll need to give it a few parameters to get started. So I'm going to call the alert CPU alert. And then I'm going to give it a threshold of 50%. And I want to notify myself via email whenever this threshold is crossed.
Okay, that's great. So let's go ahead and test this by SSHing onto the on-prem virtual machine and then stressing the CPU with the stress tool. Now, we've already downloaded this, but if you're following along at home and want to do the same, you can do so by following the command that we're about to put on screen.
Yeah, that's right. So let's run the stress tool to overwork the CPU. So this is how this program works. It just simply works the CPU hard for as long as the program is running.
And how long will it take for Azure to identify and notify us?
So it could take a couple of minutes, so let's pause the video and return in a moment.
And as we can see, here is our mail informing us that the CPU has been stressed. So with that, let's carry on with our demo. So I guess that the last thing that we want to do is begin securing our resources, and Azure makes this super easy with Azure Active Directory and role-based access control. Adam, what are we going to create here?
So we want to create 3 users, Bob, Fred and Dave, and then we'll create 3 groups named Central IT, App Dev and Ops. Finally, we'll add the users into their retrospective groups and then allow those groups access to resources.
Okay, let's jump back into the demo and build this out.
So the first thing we'll do is add our users, and we're going to do this using the CLI by typing this command out. So we're using AZ-AD user create. We give it a display name, so I'm creating Fred in this case. We also give it a user principal name, so this is the name that exists inside the directory. Now I'm using my VDC Lab Outlook domain here. If you're following along at home, you'll need to use your own domain. And then finally we give it a password.
Okay, and I mean, this is brilliant that we're using the command line, but we could also use things like comma separated values, LDIFT commands, PowerShell, and scripting to import all of these users too, right?
Yeah, absolutely. Yeah, any of those. So I'm just doing the same thing again for the other users. So I'm creating Bob here, and then Dave as well. Yeah. Okay. Now what I'm doing next is I'm going to create some groups also using the CLI. So I'm using AZAD group create. I'll also give it a display name. So this one is going to be Central IT. And then we also need to give it a mail nickname as well. So that's created. I'll create two more groups. I'm going to create app dev.
And then finally ops, right?
Yeah, that's right.
Now, to add the users to the group using the CLI, we're going to need to get the object ID of our users. How are we going to do that?
Right, so what we can do is we can run the command azad user list. And I'm going to put a query on here, so I only want it to show me the object IDs and nothing else. So I'm going to use this query string to do that.
Okay, so effectively formatting the table of the results you want returned, right?
Yeah, that's right. So I only really want two fields here. I want display name and object ID, and I want to put them in a table format.
Okay.
So we can see here that we've got all of our users with their object IDs. So what I'll do next is I'll copy and paste these object IDs, and I'm going to use those in my next command, which will add the members to the groups. So azad group member add. And then I'm going to use the member ID, which will be the object ID I've just cut and paste. And then finally, I'll specify the group that I want to add that user to. So Central IT in this case.
Okay, and the member ID is, I'm assuming, is like the user SID, the security identifier token that you would have on an on-premises domain controller, right?
Yeah, kind of like that. So we'll do the same again with Bob. Add this to app dev. And finally, we'll grab Dave's object ID and use the same command to add him to the ops group.
Okay, awesome. So our user base has been created. Let's now configure role-based access control to lock down our subscription. Now I'm thinking that Central IT should be a contributor to the VDC hub and a network contributor to the spoke hubs. Then I'd like our app dev group to be a reader to the VDC hub and a VM contributor to the spoke hubs. Finally, I would like our DevOps to be contributors to the spoke hubs only. Adam, can we demo how to achieve this?
Sure, let's jump back into the portal. Alright, so the first thing that we'll do is we'll navigate to the VDC Hub resource group and then into the IAM access control section.
Okay, now IAM is the Identity and Access Management, yeah?
Yeah, that's right, yeah. So from here we'll add Central IT to the contributor role from the drop-down box. And we'll save that. And then we'll add another role, and this time we'll add the app dev group into the reader role. Okay, now we can navigate to the VDC Spoke 1 resource group, and we'll select IAM once again. Now this time what we'll do is we'll add the app dev group to the virtual machine contributor role, which is right down the bottom here.
Again, this is taking, it's quite a cumbersome process this. I'm assuming that we can script this.
Yeah, of course, yeah. I mean, again, we can do this using the command line or the or ARM templates. So we're now going to use the portal to add Central IT to the network contributor role. And finally, we're going to add ops to the contributor role.
Awesome. Now, I'm assuming we have to repeat all of this for Spoke 2. Let's go ahead and pause the video, and we'll do that in the background so we can move on to the next part of the demo, okay?
Yeah, absolutely.
Okay, so let's go ahead and test this. Now, I'll open up a new incognito window, and I'm going to go ahead and log on as Dave. Okay, so we'll log on as Dave, type in his password. Now, because Dave is part of the DevOps group, he should have full visibility of the resources in both Spoke 1 and Spoke 2. However, we can see that Dave has no visibility of the resources in the Hub resource group. So let's go ahead and now log on as Bob, who is part of the Apps Dev group. Okay, so we'll just authenticate. Now what we'll see is that Bob will have full visibility of the two Spoke resource groups, but only read access to the VDC hub.
Yes, you can see here that if we go into one of the resources inside the Spoke resource group, we can do anything on there. We can restart things and delete resources. But if we go back into VDC hub now, you'll be able to see here that we can't actually make any changes to anything.
Yeah.
So if I just click on subnets here, you see that I don't have access to change those.
So you can view them, but they're greyed out due to the reader role.
Exactly.
Okay, brilliant. So let's now log on as Fred, who is part of Central IT. Now, what we should see with Fred, that he's able to make changes to the Hub VNet network resources, but should be unable to see any of the virtual machine resources, as Central IT doesn't have the virtual machine contributor role assigned. Is that right?
Yeah, that's exactly right. So if we go into the Hub VNet, first of all, you can see here that we're able to make changes here, so I can add a subnet if I want to. Now if I go back into resource groups, go into my VDC Spoke 1 resource group, you'll see that I don't have any access to the VM resources directly.
Well guys, we're at the end of the demo, and I'd like to thank Adam once again for taking the time to build out this architectural design with us.
No problems, my pleasure.
It's our wish that you found this session valuable, and I would like to also remind you that all of the resources used today are available to download on the Azure Citadel and your GitHub repo.
Yeah, that's right, everything's there.
Awesome. All that's left to say is for us to thank you for your time, and we look forward to seeing you on the next Citadel cast.